Snakes and Ladders is one of the most well-known board games ever, but is it possible to make it with just Minecraft redstone? Well, yes. And here's how I made it. First of all, I would like to thank mattbatwings for inspiring me to start doing logical redstone. I highly recommend watching his Logical Redstone Reloaded series if you want to learn the basics of logical redstone and want to make games like this one. This redstone game is split into 5 main parts. There's the display, the dice circuit, the turn circuit, the counter circuit, and the logic. First, I will explain the display, which is just the board. This is the design for one tile, and it consists of a number and 4 redstone lamps to indicate which players are on this tile. So for example, in this case, the orange and light blue player are currently on tile number 1. I copied this design to the entire board, which is 5 by 5 in size. A Snakes and Ladders board is normally 10 by 10, but since this is my first big redstone project, I decided to make it 5 by 5 instead. I also added 2 ladders and 2 snakes to the board. And for the redstone itself, I used something called a matrix decoder. Essentially, it takes in an X value and a Y value, and it plots a point on the grid based on the X and Y coordinates. So if I put in an X of 2 and a Y of 3, it will put the point over here. This large orange circuit behind the board is just an enlarged version of the matrix decoder. And it works the same way. As you can see, the input is X equals 2 and Y equals 3. And the point that it plots is over here on tile number 18. However, we also need something to translate the tile number, for example 18, into its X and Y coordinates. At first, I thought I needed to build a very complicated math circuit, but then I realized I'm dumb. I can just use a ROM, or read-only memory. Like in a computer, the ROM stores a bunch of hard-coded data about the X and Y coordinates. So for example, if I input 18 as the tile number, it will automatically output an X of 2 and a Y of 3. Combining the ROM and the matrix decoder, this is the whole display circuit. Of course, this is only for one player, so the final build has 4 of these circuits, 1 for each player. Next is the dice circuit. This circuit uses a shulker box randomizer to generate a random number. This dispenser contains 6 different shulker boxes, each with a different number of items inside of them. When read by a comparator, this outputs differing signal strengths. And this can be detected and stored in these locked repeaters. The data is then fed into a 7-segment display, which displays the number on this screen. Next, let's talk about the turn circuit, which keeps track of whose turn it is to move. The way it does this is by using something called a shift register, which uses locked repeaters. As you can see, this one is currently on, and the signal will travel on to the next one, which corresponds to purple. And when I press the button, that's exactly what happens. The purple lamps turn on. Next, the signal will loop back to the orange one. So, when I press this button again, you can see the orange lamps turn on. The information from the turn circuit is then fed into the logic circuit via these 4 wires and will be used later. Now for the counter circuit, explaining the redstone itself is way too complicated, so I'll just summarize it. Basically, it outputs the same number of pulses onto this gray wire as the number that you rolled on the dice. Then it outputs an extra pulse at the end while turning on this pink line, and you will see why later. Finally, we have the most important part of the redstone game, the logic that controls the actual game. The circuit starts here, at these locked repeaters. These store the tile number of each player, and then these green wires will take out the tile number while also taking into account whose turn it is. This is why we needed to take out the signal from the turn circuit and bring it over to the logic circuit. Usually, the tile number gets processed here in this adder circuit. It just increments the tile number by 1, essentially moving the player forward by 1 tile. However, if you've already reached tile number 25, but you can still move some more spaces, the game is supposed to move you backwards. So, this cyan line detects that, and when it turns on, the adder circuit will instead become a subtractor circuit. Before, I mentioned that the counter circuit outputs an extra pulse at the end, and this is used to check for snakes and ladders. When the player is at the bottom of a ladder or at the top of a snake, the rest of the logic circuit can detect that and set the player's position to the top of the ladder or to the bottom of the snake. And that's it. That's a simple explanation about how this snakes and ladders game works. If you want to try out the game for yourself or look at the redstone, there is a link in the description to the world download. I recommend setting the tick rate to 40 while playing the game because the redstone is kind of slow. If you enjoyed the video, please subscribe and comment any suggestions as to what I should build next with redstone.